So we need to find mass acceleration of this load. So let's draw a free body diagram. For this object we have its weight, upward we have a tension, and it can move only downward. Let's call its acceleration A1. So due to the Newton's second law, total force should be equal to MA, or resultant force. So basically mg minus tension equal to MA1. Now let's draw a free body diagram for our solid cylinder. We have a tension to the left, same tension, because rope is weightless, no mass, and this cylinder can rotate only in this direction. The contact point here, cylinder is rotating to the right, so friction force to the cylinder will be directed to the left. Of course we have a weight and normal force. Let's draw it here. And the center of this cylinder will move to the left, of course, because it's rotating to the left, and let's call its acceleration of the center, acceleration of the center of the cylinder, A2. Again, let's apply Newton's second law for this cylinder, and this cylinder is moving only in horizontal direction to the left, because we have a tension to the left, and also we have a friction force to the left. So resultant force acting on this cylinder in horizontal direction will be equal to this one, tension plus friction force equal to mass of the cylinder times acceleration of the cylinder. A2 is, again, I will repeat, acceleration of the center of cylinder. And at the same time, this cylinder is rotating. So basically we can apply torque. Total torque should be equal to moment of inertia times angular acceleration. We have two torques due to tension and due to friction force, because only these two forces can rotate this cylinder. Tension trying to rotate it in anti-clockwise, friction force is trying to rotate in clockwise, but we know that this cylinder is rotating at the end in anti-clockwise direction. It means torque of the tension is greater than torque of the friction force. So total torque basically equal to tension times R minus friction forces torque. This is the total torque, equal to moment of inertia of the cylinder. So we are applying torque according to the center of the cylinder, times angular acceleration of the cylinder. And the angular acceleration equal to A2 over R. Moment of inertia of the cylinder, this is a cylinder, so it will be m r square over 2. This is a moment inertia times angular acceleration, which is acceleration A2, acceleration of the cylinder, divided by radius. So further is totally mass. We can cancel radiuses. Basically tension minus friction force equal to mass times A2 over 2. Here we should be careful. Friction force did not reach its maximum value. It's unknown. Friction force is not equal to coefficient of friction times reaction force. It is not equal to, because this is a rolling without slipping, without sliding. No sliding, no slipping. That's why friction force did not reach its maximum value. You should remember. We have a friction force, but it's unknown. And we know that the velocity of the cylinder here at this point is 2 times greater than velocity of the center of the cylinder. Same we can say for acceleration. Acceleration here 2 times greater than acceleration of the center. So center acceleration is A2. So here it should be equal to 2A2, which is basically A1. because this part is attached to the rope and the wool rope is moving with acceleration a1, it means 2a1 equal to 2 times a2. Again, due to the no slipping rotation. So now we have a 1, 2, 3, and 4 main equations, and we can solve, we can find, we can calculate, we can determine A1. It's just matter of mass, matter of time. So we totally finished physics part here. First there is totally mass, and let's do it very quickly. So let me replace A2 with this one, A1 over 2, because we need to find A1. Let me copy equation number 1, mg minus t equal to ma1. Equation number 2, tension plus friction force equal to ma1 over 2. Equation number 3, tension minus friction force equal to m a2 over 2. It means a1 over 4. So let me add these two equations. So friction force will be cancelled. So tension plus tension 2t equal to ma1 over 2 plus ma1 over 4. Basically it will be equal to 3ma1. So from here tension equal to 3ma1 over 8. This is a tension. We know. Now we can bring it into the first equation. So mg minus tension, which is 3 small ma1 over 8 equal to big ma1. First is totally mass, mg equal to a1. Here we have a m plus 3m over 8, or we can say 8m plus 3 small m. From here a1 equal to 8 big mg over 8 big M plus 3 small m. This is acceleration of the load object.